So types of binary tree, we have these three types of binary tree: complete, strictly binary tree, and almost complete binary tree. In the complete binary tree, what is the condition? The condition is each node must have 2 children unless you are the last level node. So as you can see, each node must have 2 children unless you are the last level node. So this is called complete binary tree. In the strict binary tree, you have option. Okay, you can have 2 children or you can have 0 children. Okay, so this is why it's called strict. The rules are strict, that either 2 children or 0 children. And in almost complete binary tree, is basically you are not following any of this rule. Okay, there can be where for a right child, okay, there is always a left child, but for a left child there may not be a right child. Try to understand this one, that if you have a right child, there will always be a left child. Okay, but for a left child, you will not always have a right child. So that means you will either have 0, you will either have 1, or you'll have 2 children. So that's all about in complete, almost complete binary tree. There's another explanation for this one, that is when we actually fill up a tree, that means insert an element. Okay, what we do, we actually fill up from one side. Okay, so that is what is the explanation. We will see more to that whenever we are learning how to insert elements to a tree, how to delete element from a tree, and so on. But for now, remember this, there's in an almost complete binary tree, there might be 0, 1, 2 child. So we are learning the definition all actually in terms of the number of child. So these are some operations that we do, okay, in the tree. So you don't need to memorize any of this operation, just to know the name, that for a given node, okay, we can actually find who is the father, who is the left child, who is the right child, okay, the information of the tree, the siblings, okay, of that child, that whether any node has any sibling or not, what is the root of the tree, what is the size of the tree, that is the number of nodes you have, what is the make empty, that you can actually create an empty tree, okay. Then we can actually set elements to the left tree, you can set elements to the right tree, you can use this 3 type of traversal: pre-order, post-order, and in-order. And the next class, we will actually learn this tree, how to do this. This is basically almost same as prefix, postfix, and infix that we have learned in the previous stack. Okay, so these are some of the operations that you can do in a tree. And we are learning binary tree. Don't forget that. Okay, so to represent a tree, okay, we can use linked list. And I hope that you understand now that why we actually spend so much time on the linked list. Okay, we almost spend almost a whole month on a linked list. Okay, because this linked list is basically for every data structure that you use. Okay, you can, for tree, for array, for stack, for queue, okay, you can use linked list. Okay, it's basically for any projects that you do, you can use linked list. And that is one advantage of this one. So for now, we will actually use the basic simple structure, or you can use class as well. Okay, if you want to do in C++. So for every tree, we'll have 3 nodes. Okay, sorry, 3 things. First, integer info, that is what are you storing into the tree, that is A, B, C. We can call it data as well. Okay, so we'll have a data, and then we'll have another structure that will be left, right. So that is basically, it will point to the left child or it will point to the right child. So 2 other nodes. And this is where we can actually represent a binary tree. Now, this is the content that we'll cover in the next class, that is called tree traversal. Just the definition, let me just clarify the definition. The tree traversal is the process to visit all the nodes in a tree. So basically, if you want to see what nodes you have, if you want to search any node, if you want to print the nodes, you need to use the traversal. So traversal is the process by which we actually print the values or the nodes of the tree. All nodes are connected via edges. Okay, so the connection between these nodes are by edge. So A to C, there's an edge, A to B, there's an edge. There are 3 types of traversal: in order, pre-order, and post-order. So what we do, we generally traverse a tree to search or to locate given item or key in the tree and print the values. So these are the reasons of a traversal. So these are the structure as well. If you go for the pre-order, the root will come first, just like the way, you know, in a prefix, the sign, the operator will come first, and then the operand, left and right. In order, the sign will come in between, then the left and right in two side. In the post order, the sign will go last. So this is the way that we do this three type of traversal. So now let me finish here. We'll talk about in the next class, we'll talk about how to this traversals.